Archimedes' principle works for floating objects as well as objects that are completely immersed. Any floating object will displace its own weight in fluid. In this picture, you can see a boat. The boat is pressing down on the water with its weight, m boat g, and it's being completely countered by a buoyant force, which is equal to the mass of the fluid displaced times g. Clearly, the mass of the boat and the mass of the fluid displaced are the same. Consider an object of volume v sub 0 and density rho sub 0 placed in a fluid of density rho sub f. If the density of the object is less than the density of the fluid, there will be a net upward force until the buoyant force balances the object's weight and only part of the object's volume, v displacement, remains submerged. Let's look at this mathematically. What you can see on the left is a picture of an object floating on a fluid. The weight of the object is mg, and the buoyant force by the fluid is given by the density of the fluid, g, and the displaced volume of fluid. Let's do the math. We'll balance buoyant force and object weight, and then we'll replace the buoyant force with what we know it to be, basically the density of the fluid, gravity, and the volume of the displaced fluid. So remember, rho f and v displacement are the mass of the fluid. In the case of the object, we have the density of the object, its volume, so that's its mass, and then multiplied by gravity. Well, g in both cases is a common factor and can be removed. Consequently, we have the product of fluid density and displaced volume, and object density and total volume. If we rearrange this, we can find that the fraction of the volume submerged, v displacement over v naught, is given by the ratio of the object's density, rho sub 0, to the density of the fluid, rho sub f.